Hi, my name is Yongsu from University of Pittsburgh, and I'm happy to talk about our work, VISPUR, Visual Aids for Identifying and Interpreting Spurious Associations in Data-Driven Decisions. This work was completed by members of Pixel Lab at University of Pittsburgh, Xian, Teng, Yongsu An, and Yurulin. Big data and machine learning tools nowadays have been increasingly used by decision makers and analysts. Such analysis has a great potential to help discover patterns among many observations. However, researchers have found that simply looking at patterns from data at surface level might not reveal the true story, but lead to spurious associations. One example of such a phenomenon is Simpson's paradox. Think of the scenario of a governmental agent who is supposed to figure out how effective a job training program is. He wants to figure out whether the training is effective in increasing trainees' income. In a simple analysis, he might consider terminating the program because more training rather decreases their income. But when looking at data closely and separately for black and white trainees, ethnicity actually brings in confounding effects. Participation in the training program actually tends to end up higher income in both groups, and also it turns out to be effective at different rates in two groups. Analysts and decision makers might need to be cautious about such potential effects, but how can they make an informed practice? There might be several challenges. How can they identify confounding variables and find out how subgroups potentially have heterogeneity? How can they understand and explain the associations clearly? And finally, how can they make good and informed decisions given that associations might be distorted, reversed, and counterintuitive? Unfortunately, existing tools often require users a significant knowledge of causal analysis, although practitioners don't necessarily have such knowledge and strong assumption about data generation process. In this context, our study proposes practical solutions. First, a deep paradox workflow for identifying, explaining spurious associations, and informing practitioners of making a confident decision. Second, a visual analytic tool called VISPUR for supporting such analysis in practice with visualization and automatic modules available. Our visualizations play an important role in intuitively understanding the patterns, especially with two visual designs. First, covariance space is an intuitive two-dimensional visualization of the association between treatment and outcome variable. It helps easily understand how the whole population and subgroups are different in the associations. Second, Reasoning Storyboard extends the application of flow-based charts to break down how treatment leads to different outcomes. We named three different types of flow patterns to depict and explain complex paradoxical associations. To see how VISPUR works, let's take the aforementioned scenario of a job training program. The goal is to investigate if a job training program helps individuals to earn more money. Here we have had data loaded with cause and outcome variables set up. In the confounder dashboard, the untreated and treated groups differ from each other in terms of ethnicity, past earnings, and marriage status. When checking subgroup viewers and only see the population level diagram, we can see the left circle is larger than the right one, suggesting more people chose not to participate in the training program. Besides, we notice a negative association between training and outcome, seeming to be saying that the training program is not helpful at all. Then we move to Reasoning Storyboard, indicating that only 30% of individuals participated in the training, while the majority didn't. The two pathways roughly end up at the same value along the outcome axis, which seemingly suggests that training was not helpful. However, we understand that association doesn't render causality, so the negative association could be spurious, and we cannot make such a conclusion for now. In decision diagnosis, the variable black has the largest imbalance score, implying that the treated and untreated individuals hold very large differences in their ethnicity. The high imbalance scores also trigger the warning message, high imbalance. Until now, we are pretty sure the overall negative association is spurious. We move to subgroup partition and manually select black as our binary splitter and click submit. We can also compare these two subgroups through other features in covariance space. As we can see, two glyphs look very different. By comparing marriage status, 78% of black individuals were single, whereas 46% of non-black individuals were single. Next, let's move to reasoning storyboard for interpretation of paradox. We retrieved the flow diagrams for two subgroups by putting them side by side for comparison. Interestingly, we find that group 0 displays a hill-shaped pattern and group 1 a valley-shaped pattern. We realize that it is because black individuals like to take the training program, possibly due to their disadvantaged financial situations compared to non-black subgroup. So it leads to an overall negative association between taking the training and annual earnings. Until now, we understood that two subgroups are different, and the initial negative trend is distorted. But can you conclude that the training program is helpful for individuals of both subgroups? We move to the decision diagnosis for an answer. When clicking group 0, we immediately see an early message, a warning of paradoxical association. We notice that all covariates are having roughly an imbalanced score of 0, which is good. The earning message is also great. If no additional confounders exist in the case, it might be okay saying that the training is helpful for black individuals who are making more money. Then, when checking group 1, we have a warning that there is still a high imbalance. It seems that past 2 years' income are nested confounders. So, its positive trend might still be distorted, which is not a reliable reflection of true causal impact. We can go back to refine partitions to conduct a finer analysis. To refine partition, we can further add variables or use algorithm to automatically search for subgroups, and click Submit to move forward. To evaluate our study, we take a real-world scenario, the effectiveness of Java code examples in the university class, and conducted case study and user experiment. In the usage scenario, code examples seemingly have nearly zero effect, but it turned out students' performance prior to the class is a confounder. When breaking down students into low score and high score students, code examples actually helps improve the performance of students with low score. And our tool helped further find out that quit speed was a nested confounder of low score students. We also conducted a controlled user study to evaluate the effectiveness and utility of VISPUR system. We recruited 21 participants with a basic knowledge of statistics without causal inference background. We compared our VISPUR system to a baseline tool, so participants were asked to use both tools in a random order. To evaluate whether two tools can effectively provide core practices, we selected 4 tasks and questions for each of 2 application scenarios. We found that participants had higher confidence and accuracy when using VISPUR system compared to the baseline tool. While we work on the study, we found that people tend to heavily rely on their prior beliefs and easily overlook critical evidence. While our system has some limitations on scalability and applicability issues, we also find the potential of our system with further exploration as a widget to provide programming and interactive operations. In this study, we present VISPUR, a novel visual analytic system that helps interpret spurious associations, focusing on addressing Simpson's paradox. Our system provides deep paradox workflow for combating confounding biases and heterogeneous subgroups. VISPUR was found to improve awareness and understanding of spurious associations and have the capability of assisting data practitioners in making informed decisions.